Hello everyone, welcome to our channel Physics for AP. As in today we are going to do more activities. So today we are going to perform about the conversion of matter, that is from solid to liquid to gas, the activities, and we are going to do an activity upon the evaporation and condensation. So previous we have discussed about the properties of matter, that is solid, liquid and gases, and now today we are going to discuss about the conversions of matter, what the process are called, and also we will be seeing the activities. So what are we waiting for? So let us move on to our concept today. So now let us perform an activity upon the conversion of solid, liquid and gases. So already we know that the solids which convert into liquid are called as melting, and from liquid to gases we have two processes, one is evaporation and boiling. So let us do an experiment upon here. So here we have ice. So the ice are which are at 0 degrees centigrade. Now even it could be minus degree centigrade also. So let us see when we melt the ice. So now we are melting the ice. So as ice particles which are at 0 degrees centigrade, so they are about starting to be melted here. So the ice are being converting into liquid, that is water, which we call it as melting. So here the energy which we are giving for the ice to get melted to convert into water, which we call it as latent heat of fusion. So you can see the ice has been starting melting here. So ice which are at 0 degrees centigrade, if it is melted completely also, the temperature of the water will be also at 0 degrees centigrade. Why? Because the particles which are present near to the ice, that is, as in ice the solid particles are being closely attached to each other. Now the energy which we are giving it doesn't increase the temperature. It breaks the bond between the particles. It makes them break the bond between the particles and convert into liquid. So the energy which we are giving here, the heat energy which we are giving here, is used ice to break the particles which are bound together, and which is used to convert into liquid. And the energy which we are giving here, that energy is said to be called as latent heat of fusion. Now for a 1 gram of ice, to convert into liquid, which we call it as melting, so the energy which we are giving here is called as latent heat of fusion. So latent heat of fusion is the energy which we are giving here to convert 1 gram of solid into liquid. So for 1 gram of ice we need 80 calories of energy to convert it. So we need 80 calories of energy to convert 1 gram of ice. Now you can see it, the water start boiling. So now the water is being boiling here. So the liquid which is converting into gas, now it is at 100 degrees centigrade. Now it is what we call it as boiling. So you can see here the vapors. Now you can see the vapors which are present over here. So here the liquid which is converting into gas by giving some amount of energy, and also the liquid is converted into gas at a constant temperature which is at 100 degrees centigrade. So we call it as boiling. So boiling is a bulk phenomena, and you can see the bubbles. So you can see the bubbles which are coming in. So that is the reason, because there are some impurity gases which are present in the water. So those impurities gases gets evaporate along with the water vapor. So that is the reason why we are getting the bubbles. But if you take the 100% pure water, that is distilled water, you won't get these type of bubbles. Why? Because there are no impurities present in it. So the water, you won't get any bubbles over here. The water will be directly converted into vapors without getting the bubbles. And here the energy which we are giving is called as latent heat of vaporization. So latent heat of vaporization is when we take 1 gram of water and when it converts into gases, the energy which we are giving here is called as latent heat of vaporization. And for 1 gram of water, we need 540 calories to convert into vapor. So this is what we call as latent heat of vaporization. Here we have a graph of conversion of matter. So here we have A to B, that is at minus 5 degrees centigrade the ice. So at the point B, the ice starts to melt from B to C. That is the latent heat of fusion. The ice is going to be melted, and C to D is the way the water is going to be heated up. So from there, the temperature rises up 1 to 1 so on up to 100 degrees centigrade at point D, and from point D, the water starts to evaporate. So we have discussed about solid to liquid and liquid to gases. So now we will be discussing about the concept from gas to liquid, which we call it as condensation. So here we have a glass of water. So you can see, as it is kept in a fridge, so you can see the water droplets around it. So you can see the water droplets. So this water droplets is what we call as condensation. So the vapors which are present in the atmosphere, so the vapors, when it touches to the cold glass, the cold tumbler, so it converts into vapor. So when it cools, the water vapor converts into water and falls upon the surface of the glass tumbler. So this is what we call as the condensation. So the condensation is the process of converting gases to liquid state, and it is also called as the liquefaction, and it is a warming process. So why it is a warming process, that we'll be discussing further. So this is an activity to show about the condensation. The water vapors, when it touches to the glass tumbler, the cool glass tumbler, it cools down and converts into water. This is what we call as the condensation. Now let us perform an activity upon evaporation. So evaporation is a process of converting liquid state to gaseous state at any temperature. It's not same like as boiling. So boiling also occurs at liquid state to gaseous state, but it occurs at a constant temperature, like for water. So water, it occurs at a constant temperature of 100 degrees centigrade. But for evaporation, it converts liquid to gases, but at any temperature. It could be done at room temperature also. So we no need to give any amount of energy over here, but for boiling we need to give a certain amount of energy, and also it is a bulk phenomena. So that means it goes on turning, it rose on, that is the down layer of the boiling water comes up, the upper layer of the water comes down, and it moves in a continuous process, so which we call as the bulk process. But evaporation is a surface process, that is surface phenomena. So why? Because it occurs only upon the surface of the water or surface of the liquid. So here the evaporation will do an activity over here upon the rooftop of a building. So I am on rooftop of a building, so it's very hot, sunny. So now let us see, when we pour some amount of water upon the surface, rooftop of the surface, and due to the hot sun, it gets evaporated. So at normal temperature it gets evaporated. So why does it gets evaporate here? Why? Because the heat energy which is coming from the sun or which is surrounding over here, it has some amount of kinetic energy. So those kinetic energy are being observed by the water molecules which are present upon the surface of the liquid. So upon the surface of the liquid, the the liquid particles which are present, so it observes the kinetic energy on the surface over here or by the sun's energy. When it observes a kinetic energy, suddenly when it gets kinetic energy, it starts to escape from its surface. So it starts to escape from its surface. So that is why we call it a surface phenomenon, and it can be done at any temperature. So now let us perform an activity here. So now let us see the surface phenomena, that is the evaporation over here. So I am pouring some water. So some water has been spilled out upon the surface. Now let us see how much time does it takes to evaporate. So now you can see here the water which I poured before, now it was being completely evaporated after some time. So this is due to the sum of the factors which we are going to discuss now. So we have the factors which are based upon the rate of evaporation. So the factors will be discussed now. So evaporation depends upon the three factors. So the three factors that the evaporation depends upon is: one, the surrounding temperature. So when the surrounding temperature is more, the rate of evaporation is more faster. But when the surrounding temperature is low, then the rate of evaporation is slow. That means if we take in a hot summer day, hot sunny day, so the clouds get evaporate so faster when compared to in the rainy season or winter season. Why? Because the surrounding temperature is more, so the rate of evaporation is also more. That is why the wet clouds dry faster in summer season. But when you compare in the winter season or rainy season, as the surrounding temperature is little bit low, so it takes time to get evaporate. So that is why in hot sunny day the wet clouds dry faster when compared to the other seasons. And also the second thing is about the humidity. So humidity is the amount of water vapors which are present in the atmosphere. So when the water vapors are more in the atmosphere, then the rate of evaporation is less. When the water vapors, the amount of water vapors when they are less in the atmosphere, then the rate of evaporation is more. So that is in a hot sunny day during summer seasons, the humidity is very low. So due to that, the evaporation may takes faster in that time. But if you take in rainy season, so as the total atmosphere is become completely covered with the clouds, that is the water vapors, that means we have more humidity over there. So when we have more humidity, the rate of evaporation is less when you compare to the summer season. And also number 3 is the wind speed. So if the wind speed is more, the evaporation is also, the rate of evaporation is also more. But if the wind speed is less, the rate of evaporation is also less. So the wind speed also is a factor for the rate of evaporation. So we have the factors. One is the surrounding temperature, number 2 is the humidity, and number 3 is the wind speed. And also we can take another one, which is the number 4, that is the surface area. If the surface area is more, then the evaporation is fast. If the surface area is less, then the evaporation is less. That is why if you take a cup and a sauce, so most of you the people might have seen they are taking the tea into the sauce and been drinking like this. So why? Because when you compare to the surface of the cup, it is less when compared to the surface area of the sauce. So here the evaporation takes more faster when you compare to the cup. So as the surface area is more, so it gets evaporated and it becomes cold over here. And also one more thing to discuss here is evaporation is a cooling process and condensation is a warming process. So why we call like that? The condensation process. Let us discuss about the condensation process. So the condensation is a warming process, as we have seen in the activity. So if you have taken a bottle from the refrigerator and if you keep it outside, so what happened? The surface, the water vapors which are present on the surface attaches to the glass tumbler and cools down and becomes a water droplets. Now what happened to the kinetic energy of those water vapors? So the gases which are present in our atmosphere have more kinetic energy when compared to the liquids. So these kinetic energy loses out, and that means they lose their heat and cools down to convert into water. Now where does the heat goes? The heat which is been losing from the water vapors moves into the glass tumbler, that is the water which we have, and the water which is present inside the glass as it is cold. So due to this, what happened? Due to the condensation process, it becomes warm. That is what we call it as the condensation is a warming process. And why does evaporation is called as a cooling process? So why evaporation is calling a cooling process? Because the best example what we can see is our body. So our body gets sweat due to more hotness or due to more practice of exercise, or so due to that we get more sweat. So the sweat which comes outside gets evaporated into the atmosphere. So when all the sweat, the heat which is released outside, which is coming out in the form of sweat, automatically what will be present inside? All the heat is being removed out. So automatically what we'll be having is the cooling over here. And also you might have observed in some of the villages that during hot sunny day, so of the rooftop it will be very hot. So inside their house also it will be very hot. So at evening 6 to 6:30, what they will do is they pour a bucket or two buckets of water upon the rooftop of the surface to make the rooftop cool. If the rooftop is cool, then suddenly down it becomes cool. So this is what we call it as a cooling process. And also we can take on you can take any hot disk platform, and if you keep it on the hot sun, so it becomes hot. But when you pour a glass of water or a jug of water, so what happens, the water which is present upon that surface, it gets evaporated. The heat which is present upon that surface, it gets evaporated and makes the surface cool. So this is what we call as the evaporation as a cooling process and condensation as a warming process. So we have discussed about the states of matter, the conversion of states of matter, the solid to liquid, which we call it as melting, liquid to gas, which we have two processes, one is evaporation, one is boiling. So evaporation which can be done at any temperature, and boiling which can be done at a constant temperature. And from gases to liquid, which we call it as a condensation, and from liquid to solid, which we call it as freezing. And also we have a conversion of solid directly to gas, which we call it as the sublimation. So best example what we can say is a camphor. So the camphor and the naphthalene balls has been solid, and when they be kept out or when they have been light up a fire, so they are being converting directly into gases, so which we call it as the sublimation process. And from gases directly it can be converted into solid, which we call it as deposition. So these are the all the terms which we have discussed, and we have discussed about the latent heat of fusion, and we have discussed about the latent heat of vaporization, and also we have discussed about why is evaporation is a cooling process and why condensation is a warming process, and we have discussed about the difference between the evaporation and boiling. So this is about the matter in our surroundings, and please subscribe the channel if you would like it. So here we have done the activities, and subscribe the channel, share it to your friends, and click the like button if you like it, and give your valuable comment. I will be waiting it. Thank you one and all for watching the video.